So we're going to go through each question step by step by step with these practice sheets, and this will help you do the problems. You just use the same format to do the problems as the practice sheet has. So this first one says the drug Lipitor is meant to reduce cholesterol and LDL cholesterol. In clinical trials, 19 out of 863 patients taking Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of all patients taking competing drugs experience flu-like symptoms. Determine if there's sufficient evidence to conclude that more than 1.9% of Lipitor users experiencing flu-like symptoms as a side effect at the alpha equals 0.01 level of significance. So step one, is it a mean or is it a proportion? You never see the word mean in there, so it's a proportion. Okay. And we're talking about 1.9%. So our null hypothesis, step two, is going to be the proportion equals 0.019, and H1 is the proportion 0.019, and they're saying more than 1.9%, so it'll be greater than. So those are all hypotheses, and our alpha, they told us, was 0.01. So now I'll write that and then put the sample data in from the question, and then we don't have to look back at the problem. So it's a proportion question. You're just going to fill out the proportion side of this. So we're going to need to know what X is and the sample size is. So we said in the sample, we had 19 out of 863 patients. So X is your 19, and sample size is 863. So this is like your P hat equals X over N, or your successes over your sample size. Any questions? Okay. I'm going to turn, I have it written out. All right, so I have saved that. I'll be saving each of these. So now we'll go down. We're not going to be doing type 1 and type 2. It's filled out on the sheet that I posted for you, but we're not going to be doing that this semester, just to save a little time. So step 5, using StatCrunch, either T-stat or proportion stat, what are the results? So since it's a proportion, we're going to use proportion stat. So we do stat, proportion stat, one sample with summary. And our number of successes was 19. And our number of observations was 863. And we're doing a hypothesis test with P equals 0.019. And then we want it to be a test for greater than, so a right-tailed test, and compute. So here is our test statistic. And here is our p-value. So our test statistic is like a z-score. And it tells you how far you are from the mean. So we get point, let me go back. Our test statistic was Z is 0.649. Oh. And our p-value is 0.2582. Any questions? So our next step is to decide, do you reject the null hypothesis and accept the claim by comparing our p-value to alpha. Now the p-value, as an aside, is the probability that you will be wrong if you accept the claim, if you reject the null. And 25% are terrible odds. So we're not going to reject the null hypothesis because our p-value is too high. Okay, it's like 1 in 4 chance you can be wrong. So we don't reject, and we follow in step 7 the conclusion for if I cannot reject, and I say there is not sufficient evidence to support the claim that more than 1.9% of Lipitor users have flu-like symptoms. Any questions? So
no questions, but
yeah.
I just want to finish writing that
Okay.
the statement you did. So hold on 1 second.
Yep, I'm saving each one, so you can always go look them up when we're done. So what happened here? We have a proportion, 19 out of 863, which is less than 19%, but it's not less enough to say we're sure that it's less than 19% for the whole population, because it's too close to 19%. So if we
Where did 19% come from?
Not 19%, sorry, 1.9%. 1.9%. So the problem said in the population, we think it's less than 1.9%. So we used our data to see, is that data enough evidence to show that it is actually less than 1.9%. So here's our 1.9% in our distribution. And here's our data. So we had 19 divided by 863. Let me see what that is. .022.
So in StatCrunch, were we using 19 or were we using 1?
Oh, sorry, it's on the wrong side. In StatCrunch, we'll be using 1.9%. Did I do that wrong?
I think you used 19.
I'll go look it up. So
This is a little confusing.
all right, we'll do that. We'll look. Save that. Let me go back to StatCrunch. See, we used 0.019.
Okay, yep.
So
That's
it's
fine.
1.9%.
I saw
Yeah.
the count of 19. That's what it made me think of it.
Yeah, so I have a little more room to draw here. So I'm going to draw here what's going on. So here is our distribution. If P actually is 0.019, that's our distribution. We got one sample of 19 over 863, which is 0.022. So here is our 0.022, which is our little p hat. Our p hat gives us this area, which is our p-value, which is 0.2582. So that area is the probability that p hat is greater than 0.022 in this distribution, just randomly, just because we happen to get a random sample, which says 25 out of 100 times or 26 out of 100 times that's going to happen just randomly. So it's not that high. A quarter of the time it'll just happen. So we're looking for that p-value to be less than 5%, which means it's really unusual. And because if it's unusual, then maybe P is actually greater than 0.019. If we had a sample way over here, then we go, wow, that's really weird. Maybe P is not 0.019 for this drug. Any questions?
All right. So there's a 25% chance it's greater than 0.019 or 25.
0.022.
So then aren't we trying to figure out if it's like too different from 0.019?
Yeah, and it's not different enough.
Because only 25% of the time it's different.
Well, only 25% of the time you're going to get that number anyway. So that's not rare, right?
Yeah, I guess.
It would have to be less than 5% of the time. In this case, that's what the researcher wanted, and which we're not even close to that. This is a terrible. It's just not showing it's far enough away.
Okay.
So not only do we want to get something higher, we want to get it high enough that we go, maybe 0.019 is really wrong, and it should actually be higher.
Because I don't know. I'm kind of confused because the 0.019 is what the standard is for most drugs, and then this is for Lila, whatever.
Lipitor. So they think Lipitor might actually be worse. So they're testing a sample of close to 1,000 people, 863 people, to see, is it worse for them? Yes. Is it worse enough? No. It's not worse enough to say that it's not 1.9% for Lipitor too.
Okay.
It's just not enough evidence. Okay, we're going to go on to the next one. I know this is weird, but you can follow the step-by-step and keep trying. So we'll go on to the next one. It'll make more sense as time goes on. Okay.